This is a review on using the FOIL method. However, what I'm going to be going over is some concepts that will help us when we are factoring, when we're going from a sum to a product. Here we're going from a product to a sum. So, first thing we're going to look at is multiplying the first terms. X times 5x, those are the first terms, so that makes 5x squared. So again, those were our first terms. Then we're multiplying the x by the negative 1. Those are called our outside terms. So we're doing negative 1x is what we end up getting. Then we move on to the inner terms. 3 times the 5x gives us our inner terms, and we end up with a positive 15x. And then the last terms are the 3 and the negative 1. So we call those our last terms. 3 times negative 1 makes a negative 3. Well, we combine the two terms. Now notice, whenever we've got opposite signs here, one's positive, one's negative inside the binomials, our outer terms and inner terms are always subtracting when we're coming up with our answer. So we have our 5x squared we bring down. These two terms are opposite in sign, so we end up subtracting. We get positive 14x. We're always going to subtract our outer and inner terms when we have opposite signs. Also, one other thing when we have opposite signs, our last term is always going to be negative. That would be our answer. Well, let's take a look at the next one. So we're going to do our first, outer, inner, and last terms again. So the first terms are 2x and the 3x. Those we call our first terms, and that makes 6x squared. So common mistake is people will forget to put the squared symbol. X times x makes x squared. Outside terms, the 2x and the 4. So that gives us an 8x. Now we move on to the inside terms. We're multiplying 3 by the 3x. Those are our inner terms, and that makes a positive 9x. Now the last terms, the 3 and the 4, we multiply, and that makes a positive 12. So what I want you to notice about this problem is we have the same sign. When the signs are the same, we have outer and inner terms that are equal signs, so we add them together. And so here we have 6x squared, we brought down the first term, and then it's a plus 17x. And then we also always get a positive number when we have our two binomials with the same sign. So it makes a positive 12. So that's something that's different about this problem compared to the last one. Not only the numbers are different, but here they are opposite signs, so we subtracted outer and inner terms, and we got a negative last term. Here they're the same sign, so we end up adding the outer and inner terms, and we get a positive last term. So we'll see that constant pattern with all of these problems. Again, same sign, so we predict that we're going to add the outer and inner terms, and our last terms will be positive. So let's see if that's the case. Here are the first terms, and when we do that, we end up with a 2x squared. Outside terms are the 2x times the negative 3, and that makes a negative 6x. So you see that the two binomials have the same sign, so when we multiply, the outer and inner terms are always getting the same sign there. So the inner terms here, our inner terms, are going to be a negative 7x. And the last terms, the negative 7 and the negative 3 make a positive 21. So notice we have the same scenario that we predicted. So again, the 2x squared gets brought down, but the outer and inner terms are the same sign, so you end up adding them together. You get negative 13x, and our last term is positive again. So that's something that you should always look for. You're doing something right. When we have the same sign in the binomials, we add the outer and inner terms, and our last term is always positive. Let's try another one here. 2x times x. So these are opposite signs, so we'll end up subtracting outer and inner terms, and the last term will be negative. Let's see if it works. So 2x times x are the first terms. That makes a 2x squared. Outside terms are the 2x and the 4, and that gives me a positive 8x. Move on to the inner terms. We have a negative 5 and a x. And that gives me a negative 5x. And the last terms are a negative 5 and a negative, or a positive 4, and that makes a negative 20. So our prediction is correct again. It always works out this way, outer and inner terms. If we have, again, this only works, I guess, if the first terms are always the same sign here, but if our last terms of each of the binomials are opposite signs, we're going to end up subtracting the outer and inner terms. So that gives me a positive 3x, and our last term will always be negative. So that concept right there, with the last term being negative, is always going to end up helping us figure out how to factor, how to get back to this product here. This is our sum, and this is our product. So let's take a look at another one. We have 3x and 2x. Those are our first terms. So our first terms here are a 6x squared. And so then we move on to the 3x times the negative 9. Those are the outside terms. They make a negative 27x. Now we move on to the inner terms. 7 times 2x makes a 14x. So positive 14x. And the last term, 7 times negative 9, makes a negative 63. So we go ahead and do some work there. We just collect those outer and inner terms. And again, when they're opposite signs like they were, we're going to end up subtracting those two numbers. More negatives than positives, so it's a negative 13x. And our last term is always negative when we have opposite signs in the two binomials. Well, this one is one that we're going to see a lot more of tomorrow. We're going to end up having to deal with these special products. And so here's a special product. We have a sum and a difference. See, I call it a sum because we're adding, but this is a difference because we're subtracting. But they are the same numbers, just the 4's have opposite signs. So let's take a look at our first terms there. X and x make x squared. Outside terms, x and 4 make a 4x. Let's move on to the inside terms. And that's a negative 4 and an x, and that makes a negative 4x. And then the last terms, the negative 4 and the 4 make a negative 16. So something that we'll see with these problems when we have a sum and a difference is that the outer and inner terms we said would subtract because they're opposite in sign, but they cancel out in this case because they're the same number but opposite in sign. So that makes 0. So we don't have to worry about writing that down. So we're just left with an x squared minus 16. And it's a minus 16. We predicted that last term would be a negative because they're opposite in sign. And this we call a difference of squares. So a difference of squares. It's called that because we're taking a difference, we're subtracting, and x squared and 16 are both perfect squares. We could take their square root, and they would equal either x or 4. See, and the reason why they're perfect squares is because we're multiplying the same numbers, x and x, 4 and 4, but they're opposite in sign. That's why it's a difference. Well, those are the problems you'll see on part 2.